sometimes in certain equations, the variable that we're solving for appears more than once within the equation. So to do that, to deal with situations like this, we have to get a little bit clever. And this actually uses a similar principle that the previous video did, video 1, for literal equations. If you haven't checked that out yet, make sure that you go do so. Because I have an AC minus a DC equals 10. And from the previous video, we were talking about how you can reverse or undo the distributive property. Imagine a slightly different way of thinking of this. I have 3x plus 5x. I say that that's 8x. And the reason why is because I can take that 3 plus 5 and add them together. And then I get the 8x. So it's kind of the same idea here. I have an AC minus a DC. If that was, again, let's say 7c minus 2c, well, I just do the 7 minus 2, and that gives me a 5c. So that's what I can do here. I can get this so that there's only one c by writing the subtraction that I would do. If I have AC minus DC, well, that's the same thing as saying A minus D, in parentheses, times C. To use the vocabulary from the previous video, this is also like factoring. And it doesn't matter if you write the C on the right or if you write the C on the left. It's a matter of preference which one it is. Conventionally, it's the second way, the C times A minus D, putting the C out in front. But ultimately, it doesn't matter. As long as you know that these two things are two group things. The C is by itself, the A minus D is by itself in a group, which means that I can now finish. The problem initially is that there was more than one C. In order to solve for C, we have to get C by itself. And we can't get C by itself if there's more than one C. So we need to change the equation so that there is only one C. So now we can divide both sides by A minus D. We can divide by that whole set of parentheses. Cancel them out on the left side, and we get C is equal to 10 divided by A minus D. And you could write it without the parentheses, that's also okay. Because it's implied. When you have an operation in the denominator like that, it's implied that there's parentheses around that. So we get our answer. C is equal to 10 divided by quantity A minus D. We'll do another example. Notice this one's a little bit different. We have two R's, we have two P's, we want to solve for the P. The problem is, the P's are on both sides of the equal sign. In order to solve for a variable, our first step, we need to make sure that all of the instances of that variable are on one side of the equation. It's not solved for P if we have P's on both sides. Your instinct might be to say, oh, well, I can just do RP is equal to SP minus R, and then divide both sides by R. And do P is equal to SP minus R divided by R. Problem is, this isn't solved for P. We can't have a P on both sides of the equal sign if we're saying that we're solving for P. We haven't isolated the P. So we need to change this around so that all of the P's are on one side. I am going to subtract the R. RP is equal to SP minus R. But I'm also going to subtract the SP, because that is a positive SP. So now I have RP minus SP is equal to negative R. And now you can guess where this is going to go. I have RP minus SP. That's the same thing as P times R minus S. Or again, R minus S times P. Ultimately, it doesn't really matter a whole lot what order you put them in. Equals negative R. And then divide both sides by R minus S. And I get P is equal to negative R divided by R minus S. And it's okay that R appears more than once. I'm not solving for R. I'm solving for P. So we just need to make sure that the P is only in there once. Any other variable, it can repeat as many times as you need it to. That part doesn't really matter so much. We need to just make sure that the P is by itself, which it is. So we're done.